Hello, everyone. It is my pleasure to welcome you all to episode 30 ChatGPT Risks and Rewards of Generative AI in Cities. So, today I will be your host and moderator. I'm Samriddhi Shur. I'm the director of the Meta Asset Research Center at the Metaverse Council. And now we will be beginning with this IT Digital Transformation Series webinar. So before we begin, I would like the audience to note that all the questions from the audience will be taken during the Q&A session after the presentation. The participants can submit their questions by typing in the Q&A window. The Q&A icon can be seen at the bottom of your screens. Please indicate your cities and your country while you are connecting with us, and this will help us make the session more interactive. Please also note that the webinar is going to be recorded and the recordings are going to be made available on the website. The presentations will also be available on the websites for your review after the session. So this webinar will explore how the generative AI can be leveraged across sectors like health and education during the urban development and planning. To begin with today's webinar, I would like to pass on the floor to Mr. Cizo Onone-san, the Director of Telecommunications Standardization Bureau. Over to you, Mr. Onesa.
Colleagues and friends, generative AI has the potential to transform the way our urban environments function, the way we interact with our cities, and the way we envision the future. In this context, generative AI can assist urban planners in stimulating various scenarios and predicting the outcomes of different urban planning decisions, helping us to optimize traffic flow, reduce energy consumption, and create space that are harmonious with both nature and human needs. Generative AI can also support inclusion through participatory urban planning. With communities highlight their priorities, our urban planning decisions can better reflect the diverse needs of society. However, as we embrace the potential of generative AI in our cities, we must also address data privacy and security. It is essential that we establish robust frameworks, guidelines, and standards to protect personal data and ensure its responsible use. This is extremely important for sectors such as health, where generative AI can help us to deliver personalized care, enhance medical imaging, and discover and trial new drugs. Transparency and accountability are key in ensuring that generative AI steers clear of systemic biases and does not perpetuate inequalities. By harnessing the power of generative AI in urban planning, we can create cities that are not only efficient but functional, but also aligned with our shared aspirations and values. Our speakers today will share their insights on various promising applications of generative AI beyond large language models such as ChatGPT, guiding our exploration of new opportunities to improve urban planning, retail, health, and more. I thank all our speakers and all our participants for your contribution to our discussions. We highly appreciate your support. Thank you.
Thank you, Mr. Ononesa. I believe these remarks will feed well into our upcoming presentation. I would like to encourage the audience to type in any or all the questions that you may have for us, and we will try our best to take them up in the Q&A session coming up. So before we begin with the panel again, we have Dr. Rami Fathi with us, who is the chief expert of the National Telecommunications Standardization Authority. I'm sorry, it's NTRA, it's National Telecommunication Regulatory Authority for Egypt. And Dr. Fathi, over to you.
Thank you very much. Thank you, Sure, and thank you for inviting me. So allow me to share my screen. Right. Thank you. Perfect. So let us go right at it very quickly. So I'm going to share with you a presentation on the responsible use of generative AI in cities, just to streamline the discussion and bring some key ideas to the talk. So basically, where are we? Cities face a multitude set of traditional challenges. We have been discussing on these aspects for quite a few years now. Of course, we have been facing sustainability-related challenges in terms of socio-economic and environmental set of challenges. These challenges span from cities' ongoing GHG emissions to traffic congestions to some financial constraints, to energy efficiency aspects, connectivity gaps, and etc. And in order to tackle these particular set of challenges, we have also a set of technology enablers that, in a way or another, act as an enabling infrastructure or an enabling instruments to tackle these challenges. These are, of course, ICT infrastructure. You need a very sound and robust ICT infrastructure in place in order to function properly. You need IoT and smart cities technologies that could, in a way, enhance the quality of life of the city dwellers and city citizens and city residents. Artificial intelligence is considered one of the significant and very important tools, and this is actually the main focus of our discussion today. So, and of course, on top of that, a set of regulatory environment that is sound and enabler for the innovation to take place and to strive and to create a level playing field for all the companies and all these solutions to be provided on an equal basis. The smart city and the digital transformation route is a multi-year journey. Driving digital transformation and achieving smartness and sustainability is not a single point in time. It's not an action that you can actually take at a particular time. It's a journey which usually takes multiple years, and usually cities and governments have to keep up with the ever-evolving ecosystem of digital innovation. And that is why in the recent years, we have seen many policies and many strategies and initiatives related to digital transformation. And it usually starts with some specific action items, starting from empowering people or community engagement to making the technology equitable and accessible to all city dwellers or all city residents. That's the digital equity notion. The point of responsibility responsibility towards the management of the data and the management of the digital infrastructure, building trust by securing the digital assets, and building multi-stakeholder capacity engagement. So collectively, these elements form what we would like to call a people-centric approach or a people-centered smart city framework that would help local governments and city administrators to take a multi-stakeholder approach to digital transformation, and that, in our views, realizes the ultimate targets of a smart city, which is sustainability, inclusivity, prosperity, and of course, it help us achieve the SDGs. So how does the ITU support digital transformation? We start by some foundational work, probably or mainly by means of standards. Standards support all facets of smartness, and they are used in order to ensure interoperability and interworking of all the different elements and all the different technologies together. Um, we also provide joint activities with other international SDOs in order to come up with an internationally accepted and a widely adopted concept of a smart city. And of course, to name one of the potential initiatives and examples that we have been embarked on with the ISO IEC. This is the joint ISO IEC, joint IEC ISO ITU Smart City Task Force. And of course, a platform is definitely needed in order to engage with the policymakers through what we would like to call the United for Smart and Sustainable Cities initiative. It's a policy instrument, an engagement platform whereby you bring city experts as well as technology leaders. You sit together, we embark on a journey trying to identify what could be the possible means in order to satisfy or realize the requirements of a successful smart city journey and a digital transformation journey. A few words on the United for Smart and Sustainable Cities. The U4SSC is a global platform that is used to advocate for public policy and encourage the use of ICTs to facilitate and ease the transition to smart and sustainable cities. It has been established in 2016, and it's a global initiative that is supported by 16 United Nations bodies and is currently coordinated by the ITU, UNECE, and UN Habitat. And it supports cities on the digital transformation journey in order to meet their goals and targets and create the cities and communities of tomorrow. It works by driving innovation through thematic areas. Through its thematic groups, the U4SSC develops frameworks, action plans, technical specifications, case studies, guidelines, and present policy guidance for city to become smarter. One of these thematic groups is the artificial intelligence in cities. And the artificial intelligence in cities is currently led by Okan Gray, and it focuses on developing frameworks and methodologies to harness AI in conjunction with other frontier technologies like blockchain, big data, cloud computing, IoT, etc. And it intends to formulate a principles-based framework for implementing AI in cities. It does not tackle specific AI solutions in order to develop or to promote some specific technologies or solutions inside cities. It is rather vendor agnostic, which is, in our views, a good thing because it promotes for policies and guidelines and procedures and key principles that needs to be there in order to consider or in order to make sure that your city is implementing the top-notch principles that would, for example, ensure ethics, ensure security, privacy, etc. It has a set of different working groups. You are kindly, of course, requested to check the U4SSC website for more details about this particular initiatives. Now to the main topic at hand, generative AI. What is generative AI and what is its practical uses? Generative AI is a technology that enables users to generate new content based on a variety of different inputs. The inputs can be any form of data, from textual information, from visual information, from sound, videos, anything. Any data can be used, can be analyzed. Generative AI learns a representation of the data that they are trained on. So rather than training your neural network and then you drive the neural network in order to predict a new form of data set that it didn't exist before, the generative AI models learn the data, they model the data itself, and this is done by means of learning inherent relationships between the tokenized data elements present in the data stream, and they are typically some form or another of deep neural networks with different flavors, different technical elements. And on the right-hand side, you can see an image of a presentation provided by Aiden Gomez, which was one of the 8 co-authors of one of a very seminal paper which introduced the concept of transformers, a very important model or model type that is currently used for delivering or for providing generative AI models. Transformer networks are similar to recurrent neural networks. However, they are only designed to process sequential input data non-sequentially. And I will explain a little bit more about the concept. So basically, they adopt two key mechanisms, self-attention and positional encoding. These two mechanisms make transformers particularly suitable for text-based generative AI applications. Both of these technologies help to represent time and give the algorithms the ability to understand context of the different data tokens inside a particular data stream. A self-attention layer assigns weight to each part of an input. The weight signifies the importance of that input in context to the rest of the input. So, for example, if you took a particular sentence inside a particular term or a particular word inside a sentence, it tries to understand the relationship in terms of its position inside the overall sentence. Positional encoding gives that particular capability to try to understand the order in which the input words occurred. So together, a transformer is made up of multiple transformer blocks, also known as layers, and a transformer has self-attention layers, feed-forward layers, and normalization layers, all working together trying to decipher and predict streams of tokenized data. So in terms of the use cases, we have multiple potential use cases for generative AI in cities. I've picked up a bunch. One of them is traffic management and optimization. Generative AI can analyze real-time traffic data to predict congestion and to optimize traffic signal timings. It can help, of course, reduce traffic congestion, lower emissions, and improve overall traffic flows. Another very important use case is urban planning and design. It can assist urban planners and architects in creating artificial and sustainable city layouts and building designs. It can be used for creating community engagement chatbots. Of course, everyone now uses ChatGPT powered chatbots in order to engage with the chatbot in a conversational, smart conversational, and intelligent engagement experience. So generative AI chatbots can provide instant responses to citizens' inquiries about the city services, public transportation, and other sort of services. It can provide language translation services using multilingual AI translation tools. It can provide tourists with commentary services for example, in museums and touristic sites. It can provide very important tools for healthcare providers by analyzing healthcare data. It can predict potential disease outbreaks in some potential areas, optimize healthcare resource allocation. It can synthesize data development. Synthetic data is extremely useful to train AI models when the data itself does not exist or is scarce in a way. It can be used for art generation and entertainment. Imagine the possibility of a future city to walk through a museum full of art totally generated by AI. It can be used to drive digital twins, AI-driven predictive maintenance model, and 3D worlds and 3D models for simulations can be developed, can be designed using generative AI. And finally, it can be used for in the natural sciences domain. In the healthcare industry, for example, it can aid in medical research by developing new protein sequences, searching for new potential drugs, etc. So we have talked about the potential possibilities. Are there any potential threats? Absolutely. We have seen evidences of potential deep fake attacks, fake sensor data, AI-powered cyber attacks, privacy attacks, bias, and misinformation. And in order to tackle these potential aspects, we need an overarching responsible use framework that would tackle each and every aspect of such attack examples. And I will just very quickly explain my final slide and give the floor over to you. Sure. So for the deep fake attacks, you can create, of course, one can create deep fake videos and audio recorders in order to, for example, say, manipulate public perception and spread misinformation. And in order to combat that, we need to start working on fake detection tools, and AI and ChatGPT and other generative AI models can be used in order to detect fake data and fake news out there. For the fake sensor data, of course, generating false sensor data from environmental or from traffic sensors could actually lead to incorrect decisions being taken by city managers. And to combat that, one could potentially implement some cryptographic techniques or security techniques in order to secure the sensory data transmission and ensure data authentication. For the AI-powered cyber attacks, exploiting generative AI to develop highly sophisticated generative-based cyber attacks can be used, like, for example, phishing attacks or something like that. Stuff like that can be used in order to power such kind of attacks. And to combat that, an AI-driven threat detection modeling and threat detection tools can be used in order to combat against such type of attacks. Of course, privacy attacks, generative AI can reconstruct sensitive personal information from the different codes and different searches used for such systems. So one form of potential combat for such a type of attacks is to implement strong anonymization techniques, for example, or privacy preserving algorithms. For the bias, this is a very important point. Training generative models on bias or discriminative data sets, or using AI generative AI models that do not take into consideration the aspect of data distribution and the aspects of minority modes is one potential challenge. And the simple solution, of course, not that simple, but one potential solution is that you can adopt good generative models that capture minority modes in its data distribution without sacrificing the generation quality. Finally, the misinformation, generating AI-based content such as news articles and spreading misinformation can be mitigated by means of fact-checking algorithms and fact-checking and verification checking algorithms. So the atmosphere is very wide and very open. And by that, I conclude my keynote and send it over to you. I'm looking further for a very interesting discussion. Thank you.
Thank you so much, Dr. It's really a very insightful presentation. Now we will be moving on to our panelists. First, I'd like to introduce our first panelist, Dr. Yusuf Khalili. Mr. Yusuf Khalili is the Chief Commercial Officer at Autonomous. Hello, Dr. Khalili.
Hi,
How are you?
good morning. Good morning, everyone. Glad to be here with you.
Yes. So, Mr. Khalili, before we begin, would you like to please share your experience with us and what do you think about this topic, this session today?
Sure. So my name is Yusuf. I'm the Chief Commercial Officer and the President of the Professional Services Unit of Autonomous. And Autonomous is a fully owned subsidiary of Neom City in Saudi Arabia, a very bold and futuristic development that's happening in that region. And we're quite excited about the kind of technologies and innovations we're going to bring to the world. My experience spans over 30 years, pretty much in business functions within the technology domain and pretty much within the smart cities domain. And I'm going to maybe share here a few slides with the team. So good morning, everyone. I want to start actually by just maybe, if you allow me for 2 minutes, introducing the concept of what's a cognitive city versus a smart city. And this will be very helpful on the heels of the very interesting discussion here by my colleague Rami with all the explanations around what generative AI is. So we all know, we've heard about smart cities, and it's the big thing now. So going from a normal city to a smart city, and now we're advocating the cognitive city concept. And the cognitive city concept is pretty much around AI. So it's very relevant to the discussion of this session. And what's a cognitive city, and the difference between a cognitive city and a smart city is a cognitive city is not based on, unlike smart city, which is based on real-time data, a cognitive city is based on predictive analytics and understanding potential behaviors of the citizens. And there is a huge difference between the two, because in a smart city, you work based on machines, based on sensors, based on a trigger or an event. In a cognitive city, you anticipate events, you understand human behavior, and you try to build a human experience that is centric, an experience that is centric around the human. And for that, technology needs to be much more upgraded. So AI, and specifically generative AI, is very relevant to this. And another point is data. And I've heard Rami talk about potential risks. Data is definitely a concern when it comes to digitizing and automating and, you know, going to the whole cognitive layer. Because without data, you don't have any cognitive use cases or experiences. So that there must be trust, and there must be a good balance in this whole paradox between I want to be having a better experience versus what happens to my data. So it's very important that through organizations like the ITU and others, those standards are put in place where data protection and privacy is you know, taken care of. So on that point, Rami alluded to some of the use cases. I'm going to focus my discussion today rather around the positives more than the potential threats. And I'm going to explain how we at NEOM, but at large, autonomous, how we define what we call the cognitive blueprint, and what would be the impact of cognitive technology on cities. So if we go to the next slide, I've tried to illustrate here some of those let's say use cases, applications, potential work streams that could happen in cities that uses Gen AI. So Gen AI will reshape sectors. Gen AI will reshape cities, whether we like it or not. It's going to affect all aspects of our life. So from an urban planning and government services, it's going to produce and reiterate city plans across, for road, utilities, expansion, the whole digital twinning, urban planning based on demographic simulations. So generative AI will impact the way we imagine cities, not just how we operate cities. From a healthcare perspective, tailored treatments for individual patients, anticipating diseases, making sure we anticipate the next pandemics and stuff like that. So generative AI will be very, very key towards those healthcare concerns. From a mobility and a transportation point of view, again, alternative routes based on traffic patterns, optimize seamless transportation systems, trying to imagine where could be the next stop and optimize the routes is, again, something very important. From a media and entertainment point of view, curating, hyper-personalized experiences that are tailored to, say, some people think today generative AI is only used for media and content, but the future around that is not just putting a prompt and getting some media content, but it's actually going to be hyper-personalized experiences that are built against you. For instance, the media market will grow 10x by 2030, and for that, the generative AI content will unlock total new content creation abilities. As our CEO Joseph Bradley puts it, if you think it, you can do it. And this is a huge inflection point, because in the past, you needed to know to innovate. Now you need to think and ask the question. And this unlocks democratizes the whole innovation value chain. And so on, and various other sectors, from that perspective, education, the merger between metaverse or extended reality and generative AI opens a whole new door towards how our children will be educated, will consume, but also will contribute to learning. So, and then if we go to the next slide, I'd like to say, okay, so that's great. So who's going to actually do it? And what could be those concrete steps within a city from a city ownership point of view? At the current trajectory, Gen AI will have impact on the whole development cycle of future cities. So if we think of master planning as a function, if you think of the role of municipalities and how they master plan a full city, example, optimized land use planning, simulating mixed land use to define strategies that maximize economic viability and livability is a very interesting use case from a master planning point of view. And you know, or a holistic disaster readiness and, you know, flood simulations, impact of natural disasters, and trying to predict those before they happen will save serious lives and will help also with the recovery. So you can simulate recovery plans based on those scenarios. From a design perspective, so you have the planners of the city. From a designer's point of view, you know, you can think of use cases around next generation sustainable architecture. So how can you generate architecture blueprints that are optimized for hundreds of variations to meet sustainability targets? So how can you look at the various sustainability targets, then reverse engineer that and start playing with that to generate the most optimized architectures? It's really cool. Today, it's kind of after the fact. We want to make it really before the fact and work in different scenarios. Another use case is enhanced urban design. So from, you know, a whole of city population growth and activity and trajectory to support proactive planning, road, utility, power, pressure on the infrastructure. This is all something that we don't do well today, and generative AI will help us as humans to augment our capabilities and do 10x. And then you go from a development perspective, use cases around proactive compliance, for instance, scanning through building codes to highlight key compliance issues and generate proactive solutions, or rapid and efficient construction methodologies, where you can define mitigation strategies for construction issues to help anticipate and prevent delays. Do you understand how much is that cool in terms of optimizing, you know, how much is that cool in terms of optimizing city resources, and how is that gonna give back money to spend on more important things? And then from an operations point of view, you know, we could fundamentally transform city operations, for example, generating recommendations, assistance for, you know, properly purchasing and leasing, or, you know, the whole process today is inefficient because of low visibility over public information. And generative AI can access this information, harvest it, create a level field where you know, efficient and equitable access for citizens is there. And also generating optimal travel routes for public transfer offloads the pressure from the city and make sure that the operators can interfere in the case of emergencies, and optimizing those situations of emergency. So great. So now we've seen that, and eventually, how does that summarize for a city? What's the actual benefit? And my last slide, if we can go to it, it's really three things. Everything we will do and everything generative AI will help us do in terms of transforming our cities from non-smart to smart to cognitive revolves around those three areas. So one, unlocking productivity and propelling growth. So automating business as usual tasks, you know, reducing time and cost effect across business functions is crucial. And this is something that cannot even be measured, but we have ways to try to see the before and after, and the optimization of cost and increasing productivity will be huge in terms of contributions and giving back GDP competitive edges for nations. Secondly, summarizing vast data to generate insights for outcome-driven decisions is key. And, you know, again, within a competitive landscape, access to insights first gives you edge. Secondly, accelerating innovation and creativity, you know, simulating design through testing of new products across sectors and R&D and medicines and education curriculum is huge. So this will unlock, as I said, and democratize innovation and give multiple nations that don't have access to the same resources of wealthy nations the same power, because they have the right people to ask the right questions, and the tools and the machines will do the work for them. Accelerating iteration and refinement of products at unprecedented pace is also important. And finally, you know, enhancing sustainability. So as I said, livability and sustainability and happiness of citizens will pay back in terms of longevity, in terms of participation in the civic society, in terms of communications and servicing and services, participation to the various aspects of the city. So quite excited about that. I would just conclude by saying at NEOM, we embed all of this in the DNA of our cognitive blueprint. We envisage building a city that's fully cognitive and fully sustainable and autonomous. We help NEOM do this, but also we help other nations and governments do this. So I'm quite excited for being here with you, and thanks for hosting me.
Thank you, Dr. Khalili. It was really a very insightful presentation. I do have some questions for you based on your presentation. So you did mention about these cognitive cities. Now, touching upon what Dr. Fatih said in his presentation, that there are some concerns regarding the implementation of Gen AI in these urban city plannings and in development of these new areas. So how do you see regular people adopting and implementing this in their lives when we see it in healthcare? If we see it in healthcare and in education, it would be utilized by people who are more mundane, who are utilizing this in their regular lives. So, and I'm speaking this from a very perspective from my own country in India, because when we implement a smart city project, we have to think about billions and billions of people actually using it. So that's my question. Like, how exactly do you see the adoption of this generative AI being implemented when we are thinking about implementing it in education or in healthcare sector,
Sure.
which is more consumer centric?
Sure. So first of all, I have to say I just came back from India. I was part of the B20 meetings, and I would like to congratulate India for the landing on the moon and the amazing hosting for the B20 and soon the G20. Quite impressive work there. So I couldn't say enough how much the effort of the government is causing a big transformation. Secondly, so that's the whole purpose. The whole purpose is to put back the technology in the hands of people. So if you're a student, access to learning, remote learning in villages and having the same level of education is key, because now this is being democratized through technology. So connections, internet connectivity is becoming cheaper and cheaper, and the quality is becoming better and better. So giving back the technology to students to go on virtual education, and not just any virtual, but like fully immersive virtual, is something that's going to come in very soon. And it will be also augmented with generative AI. So it's not going to be just normal metaverse or extended reality. It's going to be generative extended reality. And I see this happening in the next 2 to 3 years, giving back this to the patients within their records and making sure that they are told first through multiple, we have in NEOM a health sector that's working on this. We call it the digital human, whereby all your data comes into a digital twin of you. And then imagine looking at all your data coming together and telling you ahead of a problem, may God forbid, that you should be aware of it, and explaining it from your anatomy. And so you have the users, you're right. So you have the citizens, and then you have the city planners and city operators. And at both sides, there are use cases on the front end and the back end. The only way people will use it if they trust that they are safe. And that's why I'm saying the whole ethical framework around generative AI, but the overarching use of technology, not just generative AI, is very, very key and fundamental to address. If we don't convince people that there is trust and that their data remains in their control, today when you get a banner to click and you say yes, your data goes to maybe 300, 500 pieces of organizations that you don't know about. And we at NEOM are trying to change this. At Autonomous, we're trying to change this. We're saying we're going to give you back the power of your data, and you control your data. You are responsible as a citizen, as a consumer, to say that only your physician should get this piece of your medical report, and only your educator should get the grades of your son or child, and so on. So this is where the inflection point will happen, when people feel that they can fully trust that data is private, I think that spur of innovation will start and the use cases are limitless.
Yes, that's actually amazing. I think recently the CEO of Apple, Mr. Tim Cook, he did remark that having data privacy is like having a fundamental right. Data privacy should be a fundamental right for everyone, and if autonomous is doing that, I think you're working towards liberating people and providing them a fundamental right that right now they're debarred of. So
Absolutely.
yes, yes.
Absolutely. I
So
fully
moving
vote for
on
that.
to our
Thank you.
yes, thank you so much, Dr. Yusuf. Now moving on to our next panelist, Professor Lim. Hello, Professor. How are you?
I am good, Samriti.
Yes. So, Professor, would you like to introduce yourself for our audience and tell us a bit about your work with generative AI? I can see that you've worked extensively in this field. So,
Yep. So,
yes, over to you, Professor.
yep, sure. So I'll quickly share my screen so that I can share a little bit about myself as well. So you should be able to see my screen shortly. Just give me a moment. And it should be in full presentation mode now. Yep. So Samriti, can you see my screen?
Yes, yes, I can.
All right, cool. So hello, everyone. Greetings from Malaysia. It's a great pleasure to be here and speaking on ITU's Digital Transformation Webinar, 30th episode on the risks and rewards of generative AI. My name is Professor Mark Lim, and I'm the Dean of Sunway Business School in Malaysia. Since the theme of today's webinar is not only about technology, but also about cities, I thought, it would be appropriate to give you a quick glimpse of where I'm located. So Sunway University is located in Sunway City, which is about 20 km outside of Kuala Lumpur. And as you can see on screen, this is how the city looked like in the 1980s. It was literally an abundant tin mining land. And it was the vision of the founder and chairman of Sunway Group, Tan Sri Jeffrey Chia, who saw the potential in the land when others did not. And for your information, Sunway Group is one of the largest conglomerates in Southeast Asia, and the group has made their name as a master sustainable city builder. So now let's get on to the topic that I was invited to speak on, which is on generative AI in education. Earlier this year, we witnessed the rise of generative AI, which was popularized by ChatGPT. And in education, generative AI is as much a disruptor as the COVID-19 pandemic. And with any disruptor, there is always the good and the bad. So today, let me share with you some paradoxes about generative AI in education based on an article that my team and I wrote recently and published in the International Journal of Management Education. So let's start with a simple definition of generative AI. And in essence, generative AI is a type of artificial intelligence that can generate human-like content in response to complex and varied prompts. And this could be anything from writing text and composing music to generating images and videos. And unlike other types of AI that are designed to sort data or make decisions, generative AI is made to be creative and come up with new things that did not exist before. And examples of well-known generative AIs includes OpenAI's ChatGPT, DALL-E, and Google Bard. Our focus for today will be on 4 key paradoxes that highlight generative AI's potential and pitfalls in education. But before we dive in, let's clarify what we mean by a paradox. So in essence, a paradox is a situation or a statement that might appear to contradict itself, yet might be true. So in other words, it is a complex issue that has both positive and negative aspects that may seem to conflict with each other. And as you see on screen, I can resist anything except temptation is an example of a paradox because giving into temptation means it cannot be resisted. Now, the current discourse surrounding generative AI and its impact on education highlights the inherently paradoxical nature of generative AI and its role in education. It could destroy some education practices while at the same time supporting them. So to explore these conflicting ideologies, we present 4 key paradoxes of generative AI in education in our paper. So on the one hand, generative AI is a friend, right? When it facilitates knowledge acquisition through timely and human-like response in that sense. Now, imagine a student stuck on a complex math problem. Generative AI, like ChatGPT, can instantly provide step-by-step solution, enabling students to learn on demand. On the other side, which is on the educator side, generative AI can be used to design assessments and validate the constructive alignment of these assessments against the learning goals. However, generative AI can also be a foe. What if students use generative AI solutions that they directly use for their assignments? Would this be appropriate? Answer is obviously not, as it raises ethical issues around plagiarism. The key implication here, therefore, is that we need to use generative AI thoughtfully to preserve the quality of education. This means that as educators, we need to move away from the assumption that students, by default, are inclined to cheat. Instead, educators will need to take on shared responsibility. For example, by reimagining our assessments and designing them in a way that students cannot rely solely on generative AI to write the assignment, which can be done by mandating students to use recent statistics and research-related information like institutional reports and journal articles that generative AI does not have access to, as they're typically subscription-based. Now, moving on to our second paradox, generative AI is remarkably capable. All right. So just think about chatbots in online courses that can answer student queries at any time. Right. So it's quite capable in that sense. However, the quality of the responses that generative AI generates is typically dependent on how well that AI has been trained and the kind of prompts it gets. So the key implication here is the need for user education. Specifically, we need to train educators and students on how to use these AI tools effectively. This is where prompt engineering is critical. For example, let's say a student is using a chatbot tutor to understand the concept of photosynthesis, right? A poorly engineered prompt like explain photosynthesis may provide a very basic or overly complex answer, leaving the students more confused than enlightened. However, with prompt engineering, educators and students can fine-tune their questions for more targeted and effective responses. They could use prompts like, can you summarize photosynthesis in 2 sentences for a 5th grader? Or explain the role of chlorophyll in photosynthesis for an advanced biology student. And by doing this, what is happening is that you're essentially guiding the artificial intelligence, the generative AI, to provide the level of detail and complexity that suits the learner's needs. And this ensures that the AI's capability are harnessed to provide maximum educational value, making it an effective teaching aid rather than just a source of information. Moving on, the third paradox underscores the tension between the accessibility and the restrictions inherent in generative AI. On a positive note, generative AI tools can be used by anyone, anywhere, making quality education more accessible. So imagine a student in a remote village accessing a world-class tutoring through AI, right? So this is very empowering in my view, but there is a caveat. These tools often come with freemium models that limit features or usage. For instance, some platforms may limit you by the number of prompts or the word count. And therefore, it is important to remember that not everyone can afford premium access. And in educational settings, we should aim for a reasonable response time frame from these AI tools. And this will ensure that even those without premium access can still benefit from what generative AI has to offer in a meaningful way. And finally, the fourth paradox talks about the psychology of restrictions, right? So the more you ban something, the more people want it. And this is known as the Streisand effect. If a school bans generative AI for the fear of cheating, it may inadvertently make the tool even more attractive to students. And my take on this is that generative AI is inevitable, and banning it will likely drive students to want to access it more through heightened attention and psychological reactance. And therefore, instead of banning, education institutions should look to harness the power of generative AI in a responsible manner. And they can do so, by developing guidelines for using generative AI and taking on a shared responsibility in how learning is curated and how assessments are being designed and implemented. So in summary, generative AI in education is a double-edged sword, right? It can be both a friend and a foe. It can be capable yet dependent. It can be, it can be accessible and yet restrictive at the same time. And paradoxically, it can be even more popular when banned. So what should we do moving forward? First, let us shift our perspective and treat generative AI as a tool rather than a threat, right? So in that sense, we should leverage its capabilities to enhance educational outcomes. Second, education about the proper use of these tools is crucial. So what this means is that we need to train both educators and learners to use generative AI responsibly. Third, we must prioritize equity to ensure that the transformative power of AI is accessible to all, not just those who can afford the premium features. And lastly, this is an evolving field. So what we really need to do is to continuously evaluate and adapt our approaches for better results. If you'd like to learn more, do check out the full article, which you can download for free. All right, you will be able to see some of the interesting prompts about what generative AI can and cannot do, and how they lead to paradoxes that I've just shared, as well as a more thorough discussion on the implications of these paradoxes for the future of education. So thank you very much for your attention, and let us do our future generations justice by forging a responsible and equitable path in harnessing the power of generative AI.
Thank you so much, Professor Lim. It was a very nice presentation from your side. Now, our audience does have a few questions for you. How do you measure and control the data quality for generative AI? I remember that Dr. Fatih, in his presentation, he did say a lot of things that we can utilize, such as training the model in a proper way, and again, using cryptography and other tools to provide more protection, more data control in building these models. So, what, according to you, would be a viable way, a very suitable, feasible way to create a better controlled model for generative AI, which also has a good quality data, which is not discriminative?
Yeah.
Yes.
So as with any artificial intelligence, machine learning, or deep learning model, you need to actually train it, right? But I think when it comes to education, and I think humanity in general, we should not treat whatever that generative AI tells us as true itself. I think what needs to be done is that we got to use the output of generative AI as a start. And then what we got to do is to do a lot of fact checking, meaning that whatever generative AI tells us, we need to actually check whether this fact is true. And even if this fact is true, is it true, 10 years ago, and does it still hold the truth in the current and present age? So what really needs to happen is the fact checking got to be done. And when it comes to fact checking, at the current moment, generative AI on its own do not have access to a lot of subscription-based database. For example, your Euromonitor market reports, the journal articles under Elsevier, Taylor and Francis, Wiley, and so on. They don't have access to all of these, all right, kind of databases and evidences. So they cannot actually give you and pull you the latest evidences, statistics, the state of the art, current state of the world. They can't actually do that for you. So what we really need to do is whatever that's been generated by generative AI, it's a start. Again, human intervention is necessary. Humans got to think about whether this makes sense. That's number one. And number two is whether this is still relevant to this society based on evidences that are there. Otherwise, AI, machine learning, deep learning, all those can be trained by, the methods that we already know. But I think I got to emphasize is the human oversight of what's being generated that is most important moving forward.
I do agree on this. There has to be a human-centric approach, a human oversight, which is necessary for the entire AI to function properly in a just manner. Another question we have from Ravi Solanki: how do generative adversarial networks (GANs) work, and what are the primary use cases for them?
Yeah, so
I
currently
believe.
I'm not, so I don't have the technical knowledge or know-how. My area is really on understanding behavioral psychology, on how people actually react to these kind of things. So my concern is really in terms of, okay, so now there's this new technology, how will people react to it? Will, humans become the servant of robots in the future and stuff like that? How can we actually prevent that from happening? Yeah, so my area is in that sense. So I could not answer that question. So very sorry on that.
Okay. So the next question, the last question actually from our side is that um, from Miss Melody Musoni, I'm sensing a catch-22 situation here. We need AI to address the risk brought about by AI.
Yeah.
Do you agree with this?
Yeah, so
Yeah.
I think if you use a generative AI, if you ask them about the risk, they will also tell you that they can only provide some ideas, but the accuracy still has to be checked by the user itself. So even generative AI tells you that you cannot fully rely on it, and you also go do your fact checking over there. So the catch-22 is definitely there, but hey, at least we have these two, it is better that we do not have these two. So this tool actually helps us a lot. I think for us, we just need to make sure that we are good detectives and making sure that things that we present and we use for generative AI, we take responsibility for it, and we actually do our fact checking to make sure that whatever that we use for generative AI is actually true. All right, as you can see, in many publication outlets, the top publication outlets like Nature and Science, you will realize that they have come up with a statement to say that generative AI cannot be an author of a publication because they cannot take responsibility for the factual accuracy of those information. And it is humans themselves that should be taking the responsibility and accountability for the accuracy of the information that they actually present or publish.
Very true. It's actually, I've seen ChatGPT and other language models to say that I'm just a language model. I cannot really answer this question, and this does not really falls into the ethical area of my work, so I won't be answering this question. So it does happen a lot. I think the key to the answer to this solution and this question would be to through human-machine collaboration, and that it exists with almost every technology that comes in place. Ultimately, it's humans who should be more responsible with the use of the technology. So thank you very much, Professor Lim. We will be now moving on to our last panelist of the day, Gabriel Knowles. Yes, Knowles. Hello, Mr. Knowles. How are you?
Hello, I'm great. Greetings from Berlin to everyone, Berlin, Germany. First of all, yeah, thanks a lot for having me here. I will just share my screen.
Yes.
Okay, so yeah, I'm very happy to present to you today our work Diff Infinite, diffusion model to generate large histological content. So I'm talking about a particular use case now of generative AI to histopathology. Yeah, so as you can see, there are a lot of other people involved in this project from also other institutions. We all came together for a German research project called Surreal. We are funded by the German Ministry of Research and Education. And yeah, I'm very happy to present the final paper, the final output of this research project to you today. So I first want to state the challenges in AI for histopathology. So of course, the short list that you see here is not at all a comprehensive list of all the challenges, but these two challenges are the challenges that we try to address in our work. So what you see there is the data acquisition in histopathology. So on the left-hand side, you have the tissue slide prepared for the microscope. And in the middle, you have the whole slide image. And these whole slide images are up to 100,000 by 100,000 pixels. So this is way too large to be directly consumed by a downstream AI model. So the usual approach is to tile this whole slide image into small patches and then apply a downstream model on these small patches, for example, to classify if there is cancer or no cancer on the slide. So the first challenge is that we deal with really large whole slide images. And the second challenge is that normally in histopathology, the data set is very small and it's also sparsely annotated because the data acquisition is very costly. And for example, if you think about creating a segmentation mask for the whole slide image, there needs to be a pathologist to sit down and spend a lot of time to classify all the pixels. So the approach we present here to tackle these two challenges is to train a generative model on a small and sparsely annotated data set to augment this data set and to hopefully improve the performance of some downstream application. And how do we tackle the first challenge? So the problem is when you only train a generative model on the small tiles, you will not be able to capture the long-range information or the long-range correlation within the whole slide image. So in our approach, we present a method where we generate a large image that captures to some extent this long-range correlation of the whole slide image. So yeah, the generative model that we choose as a backbone for our method is the so-called diffusion model. So here you see a high-level description of these models. So on the left-hand side, you see a sample of the data, and you have a forward process that iteratively transforms this data into noise. And during training, you learn these iterative steps from data to noise. And during sampling time, you apply this learned transformation in a backward process to go from noise to a sample of the data, hopefully. So diffusion models have shown to be able to generate high quality and diverse data, and they are theoretically quite well defined. So you can really prove that in theory, this distribution transformation from the data to the noise and backwards works well. And the drawback of diffusion models is that they are relatively slow at sampling time because of this iterative scheme. You need to evaluate the trained model on every step, and for that reason, it's quite slow at sampling. So in our method, diff-infinite, we use a semi-supervised approach for training this model. So it means we use a mixture of labeled data, of 5,000 labeled data tiles and 250,000 unlabeled data points. And we use the classifier-free guidance approach that uses a mixture of a conditional model and an unconditional model. And on top of that, we train a diffusion model only on the segmentation masks. And then in the first step for the image generation, generate a segmentation mask and then use this segmentation mask for a guided image generation. So in this figure, I tried to do a high-level description of our method. So what you see there is one step that happens within like one step of the diffusion model. So first, we generate a segmentation mask, we upscale it to the desired size, and then we randomly select a region of our large image, and we look at the corresponding region in the segmentation mask. We look at the conditions there, and for every condition, we evaluate one step of our generation scheme, such that we get for every condition a prediction. And then we use an indicator mask that is 1 where the condition is present and 0 everywhere else to aggregate all these predictions. And we then repeat this step after we cover the large image with random crops of sub-images until we have a prediction for every pixel. And doing so, we take into account all the neighboring pixels for prediction of the region that is marked here. So eventually, all the neighboring pixels are used for parts of the region to be predicted. So we compare our method to other methods that try to generate large images. And we see that our method performs better with respect to improved precision and improved recall compared to diff collage, which is another method to generate large images. And we also visually see an advantage that our method does not generate tiling effects. So these tiling effects arise in diff collage because you use a sliding window approach for the generation. And in our method, you do not observe these tiling effects. So here are some example samples generated by diff-infinite. And on the right column, you see an example of our conditioning. So we have here artificially square conditions, and you really see the difference of the classes here in our generation. We also trained a model for classification and segmentation. And we tried now to augment with our generative AI the data set and try to improve the performance. So we trained this model first on real data, then we trained only on synthetic data, and lastly, we trained on a mixture of real data and synthetic data. We see that augmenting the data improves the performance in 3 out of 4 cases slightly. Surprisingly, we see in the classification tasks that training only on the synthetic data gives the best performance when we evaluate our model on other different data sets. And in the segmentation task, we observe that augmenting the data, so augmenting the real data with the synthetic data really improves the performance of the downstream model. So coming back to the 2 challenges from the first slide. So the challenge that arises from the large whole slide image, that other generative models do not capture this long-range information and long-range correlation. We are able to approximate this long-range information, long-range correlation, In our paper, we show that we are able to generate up to 8,000 by 8,000 pixels. I mean, this is still not the size of the whole slide image, but theoretically, we could upscale our method to any desired size. And the second challenge, I think we successfully managed to augment our small and sparsely annotated data set and improve at least a bit the performance of some downstream tasks. And so the last point I wanted to comment on is the question if the data that we are generating, if this data is private, so if the privacy regulations are met by our model. So on the left-hand side, you see a visual evaluation of, in the first row, the synthetic data, and in the second row, the real data. So we computed for every synthetic data sample a nearest neighbor in some feature space. And we see visually that the real data is quite close to the synthetic data, but in these examples, we do not observe data copying. So we only generated like 10,000 images. So there is work that shows if you generate up to millions of samples, you will eventually memorize some of the training data that you used for training. So, I mean, we cannot exclude that we will never copy training data here, but at least in the examples that we generate in these 10,000 images, we do not observe it. And as well, we did some quantitative evaluation, which shows that our model is at least not prone to data copying because it reaches really high scores, especially when we generate a large image and resize it to the size of the training samples, because I think the method that we present kind of interpolates between different tiles. So for that reason, I think it makes sense that we score really good on these privacy metrics. But of course, we cannot say with probability equal to 1 that we will never copy training data. So it's still a question if the measurements that we took is good enough to say that we will never copy training data. Yeah, so in the end, I would like to thank all we are grateful for all the fundings that we received, and especially we would like to thank the pathologists who took part in this project. And you can also find a survey with the pathologist in our paper. It's, yeah, if you want to check out the details, it's on archive. It's currently under review for NeurIPS. And if you have more detailed question, please, yeah, you can also write me an email or ask it now. And yeah, I really, really thank you for your attention and for the opportunity to present our work here. Thank you.
Thank you, Mr. Novis. It was really nice to see a technical presentation discussing about how AI actually works, talking about histopathology and the analysis that you've showcased to us. I think that the cure to cancer might just come from AI, a collaboration with the doctor and an AI. Now, I do have one question here. You said that you have been utilizing a lot of private data. May I ask about are you using synthetic data as well while creating these models and while doing your analysis? Because coming from the council, we have been working a lot on synthetic data since a lot of the data that we require does not exist in the public domain. And if you do utilize synthetic data, do you see any limitations in that?
Yeah, so I think so to me it's not clear whether if we train a generative model how much new information we actually generate. So I think generative models are quite good in capturing the information from the training data and reproduce that information, but I'm not sure to what extent it really generates new information. So if the generative model really generates new information, we should see a large performance gain in a downstream task, because these additional information could be picked up by a downstream model. And yeah, we only observe slight performance gains. So yeah, I think the model sometimes generates new information, but yeah, not very rarely, I would say, still. So there can be improvements for really yeah, forcing the model to generate new information.
Okay. Now, one last question from our side. where do you see this future trend going with the generative AI, specifically in the healthcare sector?
Yeah, I think so, especially when you have data that you cannot share with public, it's a really good method to generate data that is not restricted by these privacy regulations. But of course, we need to make sure that these privacy regulations are not violated. And I think there's still some work for like a standardized mechanism to test if the model does not violate these regulation. And yeah, so in general, in generative AI for science, I would say there are a lot of interesting applications where generative models are like really used to try to solve scientific problem itself. So for example, generate biological structures. And yeah, I think these applications are also very interesting and promising for the future.
Okay, thank you so much, Dr. Novis. It was really a pleasure having you here with us today. I would now like to take this opportunity to thank all our speakers and panelists to take out time from their busy schedules to be here for this exciting discussions and sharing their insightful presentations with us. I believe that this would help us in building and developing standards in these technologies in future as well with ITU. Back before we conclude this episode, please note that ITU will also be holding more such episodes in future through their digital transformation webinar series, and you're welcome to join them, and you'll be able to see the recordings on their official website as well. Now, I would like to announce that this session and some of the future sessions as well will be hosted in collaboration with the Metaverse Council. And the colleagues have provided the link in chat for all of you to access those webinar series. So feel free to check them out. And in case you want to revisit this session, please check out the website to once again have a take at this insightful conversation. Thank you so much, everyone. It was really a pleasure having you all with us. And have a nice day.
Thank you.